Okay, Math 1 folks, here is your Module 20 to 21 practice test. Reminder, I always say this, but if all you do is watch me do it and then you try and just repeat what I do, you're really not going to get the benefit of this. So the best way is for you to work through as much as you can. And then any place you get stuck, only play this video up to the place where you're where you get unstuck, and then do the rest by yourself. Much better to make mistakes, check them, and then go fix them than to not do anything so that you can get it right the first time, because you're getting it right watching me rather than getting it right doing it yourself. So those mistakes actually help you learn better than just watching me do it right. So make the mistakes, but do it yourself. That's the best way. Okay, write a congruent statement for the two congruent triangles. So a congruent statement means that we need a congruent sign, and this would be triangle GBP. Any order is fine. Is triangle congruent to triangle SGF. And then we want congruent statements based on the diagram for all pairs of congruent corresponding angles. So that means I have to identify which angles match up with which ones. G matches up with S. So I'm going to be grading on do you do 3 letter angles. So this would be angle BGP is congruent to angle GSF. We really shouldn't have G there, should we? That's why we can't just do angle G, because obviously those are not the same angle. We've got one line and 2 lines. Angle this one and that one. So this is going to be angle GBP is congruent, whoops, forgot the congruent sign, to angle SFG. Now, when I'm doing angles, GSF and FSG, those are okay to do either way. But the S is in the middle because that's where I make the turn. That's where the angle is located. And last one, so we've done this angle is congruent to that angle. We've done this angle is congruent to that angle. Let's do this one, angle BPG is congruent to angle SGF. Okay. All pairs of congruent corresponding sides, so this is BP is congruent to FG. Notice that this is between the angles that are congruent to each other, and they're also marked that way. GP is is congruent to SG, and side GB is congruent to side SF. Any order here is okay too. So BP and GF is fine. It's okay. And there's not a right order of statements. So lots of possible ways you could write this. But what I would be checking is, do you have the middle letter correct? Notice that I've got 3 different middle letters, and they all line up based on what the diagram says. Find the measure or length using the diagram given that these 2 triangles are congruent. So looking at that, I can see that this is an obtuse angle, so this must be 105 degrees. So then the third angle is going to be, so together these are 142, so the third angle is going to be 38, because all of those together, watch, plus 38 gives me 180 degrees. So this is going to be 38 degrees. and this is going to be 37. Notice I'm going to write it in the diagram, and then I'm going to say, okay, from here is 12, and from here is 17. I'm just writing it in, then I can transfer it to my answers here. So the measure of angle Y is 105, the measure of angle Z is 38, measure of angle C is 37, and the measure of angle of side BC is 12. Just way easier for me to write it in the diagram, make sure I've got it in the right place, and then transfer the answers. Okay. This one is a conditional logic statement for ASA congruence in if-then form. So I need an if, a hypothesis, and then I need a conclusion, a then. And ASA means that we're looking at two triangles, and we see that angle, a side, and an angle are all congruent in that order. So how would I say that? Well, there are lots of different ways, but I could say if a side and the two attached angles of one triangle are congruent to the corresponding parts on another triangle, then they are congruent. Okay? If, then. This is a way of, in words, explaining what ASA congruence is. So I'm going to give you a congruence postulate, and I want you in words to put it in an if-then. And then I'm seeing, can you write a converse? So if two triangles are congruent, then a side and its attached angles on one triangle are congruent to the corresponding parts on the other. So I'm going to read this again. If two triangles are congruent, then a side and its attached angles on one triangle are congruent to the corresponding parts on the other. So you see I've got an if, a then, and then the converse is to reverse this. Okay? Now, for number 5, I'm giving you lots of different triangles combinations, and for each one you have to say either they're proven congruent by one of these 4 postulates, or they are not, and then you write none. So I'll go one by one. A, side is congruent to side, the one that, so always whenever we have two triangles that are touching each other, if the sides are exactly the same length, we can say, okay, there are two triangles and they share a side, therefore there's at least one side that's congruent. So this is angle, side, angle. B, side, side, side. C, angle, side, side, or side, side, angle. So because side, side, angle is not a valid congruence proof, we would write none. D, I have angle, side, and then I have vertical angles here. So this is ASA. E, side, side, side. F, vertical angles here, so I have side, angle, side. G, I have them sharing a side, so this is side, side, side. H, I have side, angle, side here, but look here, this is side, oops, my angle is somewhere else. So if there was an angle here, If this is where the angle was, it would be side, angle, side. But there are different orders, so no. So that's none. Okay, and here I have vertical angles again. So I have angle, side, angle. For the following triangles, write a conditional statement in if-then form that would prove the triangles are congruent according to the postulate given. Okay, so I'm trying to find angle, side, angle. So for this one, I have a side. So I would need two angles to also be congruent. That means I'd need these to be congruent and these to be congruent. So if angle DAC is congruent to angle BAC and angle DCA is congruent to angle BCA, then triangle ADC is congruent to triangle ABC. Okay, that's what a conditional statement was. I said there are two things that have to also be true in order for these triangles to be ASA congruent. Now I've got SAS. Well, here I've got vertical angles. So I've already got an S and an A. I need this side. So if EB, remember, either order when you're doing a side is fine. So this could be EB or BE. EB is congruent to DE. Then triangle ADE is congruent to triangle BCE. All right, AS. Angle, angle, side. So I've got an angle, I've got a side. That means I need an angle here and an angle there. So this would be if angle MNK is congruent to angle MLK, then triangle MLK is congruent to triangle MNK. HL, so we need hypotenuse leg. All right, so we have a PS is already congruent to PS. So this is not the answer. I'm just noting what I already know. And I already know that RP is congruent to PQ. This is the hypotenuse. Here's a leg. So I already have hypotenuse leg, right? How do I have to, what else do I have to prove? Well, actually, I don't know if this is the hypotenuse unless those two are right angles. So a couple of things I could do. I could say if RSP is congruent to QSP, that implies that if this is congruent to this, then that means that they are two angles that are of equal measure and they're a linear pair. Therefore, they're 90-degree angles. Therefore, this is hypotenuse leg. However, it might be more direct to say if angle RSP and angle PSQ are 90 degrees. Then triangle PSR is congruent to triangle PQS. And finally, side, side, side. Okay, I already know these are congruent because these are vertical angles. However, for them to be side, side, side congruent, I would need to know if VW is congruent to ZY. Then triangle XVW is congruent to triangle ZXY or XYZ. Okay, so there's our triangle congruence. Then we have angle relationships. So I've noticed that I have vertical angles here and linear pairs here. So really it's a matter of figuring out which is the best one to solve first. If I want to solve for x, then I've got to know either the measure of this angle or the measure of this angle, or it has to have another expression with x in it, so I can have a single variable. But I don't. Both of these have y, so that means x I can't solve for until I know one of these angle measures. But since these are equal to each other and they both have the same variable in it, I can set up an equation that says this is equal to this. If you're not sure what to do, set up as many equations as you want. You know, I could say 7y plus 8 plus 6x plus 17 equals 180. Now that's true, but I'm going to see, oh, I've got an x and a y term, and so I'm kind of stuck there. But this one, I can solve for y. Subtract 7y from both sides, add 3 to both sides, and I have y equals 11. So y equals 11, that means this is 7 times 11 plus 8, so 77 plus 8, which is 85. So now, instead of a y here, I can plug this in and say this whole thing we said was 85. 85 plus 6x plus 17 equals 180. So here we've got vertical angles, and this is a linear pair. Two angles, pair, make a straight line. 85 and 17 are 102. 6x plus 102 equals 180. Subtract 102. And I have 6x equals 78. So x equals 13. All right, last one. Given the angle inside shown, draw a third side on each so that there are two possible non-congruent triangles that show why SSA is not a valid congruence postulate. In other words, I need to have a side-side angle here that is the same side-side and angle on here, yet they will not have the same, they will not be congruent triangles. So you could use a ruler in class if you want, but it's actually pretty easy to just kind of eyeball it and say, look, that and that. Right? These are two possible ways to draw this. Okay, so I have an angle, a side, and a side, an angle, a side, and a side. Both of them have the same angles and sides, and yet they are not congruent. So that shows why SSA is not a valid congruence postulate. All right, there's your review. I encourage you to make sure that you've gone over each of these things, particularly practiced your if-then statements, and make sure you've completed all your homework, because that practice is what's going to help you prepare. All right, I'll see you in class, or on the test day if you're already in class and watching this.